Hi, in this video, we will see detailed review of these two amazing LoRa development kits, Wio-E5 Development Board and Wio-E5 Mini, which are manufactured by Seed Studio. We will see their features, specifications, data sheets, AT commands configuration guide, and we will also see demo of serial configuration of these boards via AT commands. So, let's get started. Hello all, welcome to Make to Explore channel. First of all, thank you to all our subscribers, viewers and supporters. In this video, we are going to see and review these two new devices. LoRa development kits, those are Wio-E5 Dev Board and its compact version, Wio-E5 Mini. Both boards are suitable for rapid prototyping and building small-size prototypes of LoRaWAN wireless IoT devices with a long-distance communication range. These boards are manufactured by Seed Studio. We will know more about Seed in later part of this video, so without any delays, let's get started.
Before starting actual device review, let's first see some brief introduction to LoRa technology. What does actually mean by LoRa? So, LoRa is a wireless communication technology that offers long-range, low-power, and secure data transmission for machine-to-machine and IoT applications. It is same as other wireless technologies which we used in our day-to-day life, like Wi-Fi, Bluetooth, Zigbee, etc. But there is a difference in their range of coverage. Let's see this diagram. So here are a few commonly used wireless technologies, like Bluetooth, which ranges up to 30 feet. Wi-Fi ranges up to 200 feet. Zigbee ranges up to 1000 feet. And LoRaWAN ranges up to 10 kilometers. So, in technical terms, LoRa, which means long range, is a physical proprietary radio modulation technique. It is based on spread spectrum modulation techniques derived from chirp spread spectrum, CSS technology, which has low power characteristics like FSK modulation, but can be used for long-range communications. It was developed by a company named Cyclio, based in Grenoble, France, and later acquired by Semtech, the founding member of the LoRa Alliance. Semtech means Semtech Corporation, is a supplier company of analog and mixed-signal semiconductors. Since LoRa is used for wireless communication, there will be communication between different LoRa nodes. So, eventually, another very important concept comes into picture, the networking. Network of LoRa is called LoRaWAN, means low power, long range, wide area network. LoRaWAN defines the software communication protocol and system architecture. These are nothing but standard set of rules with which we should communicate using LoRa technology. So, who manages this protocol? The LoRa Alliance. LoRa Alliance is an open, non-profit association of companies with over 500 members who supports, manages, and promote the global adoption of the LoRaWAN. This alliance is dedicated to promoting the interoperability and standardization of LoRaWAN. Okay, these all are basic introduction about LoRa and LoRaWAN. If you want to know more about LoRa technology, you can also check out our previous videos about LoRa, where we have explicated in-depth and thorough information about LoRa, LoRaWAN, difference between them, related protocols, networking stack, operating frequencies, and applications of LoRa, etc. All have been explained in detail. You can click here on I button, or links are also shared in description of this video. So, we are going to test these two LoRa development kits. You may have noticed that both of these kits consist of the same chip, which is Wio-E5 STM32 WLE5JC module. Wio-E5 is a low-cost, ultra-low power, extremely compact, and high-performance LoRaWAN module designed by a company named Seed Studio. Let's know more about them. Seed Studio is a Shenzhen, China-based electronics and semiconductor manufacturing company, which mainly works in wireless communications and IoT domains. Let's go to their website. Here is the one. So, Seed Studio is the IoT hardware enabler, offering a wide array of hardware platforms and sensor modules, ready to be integrated with existing IoT platforms. Paired with partners from silicon to the cloud, Seed empowers IoT developers to realize their products. You can see, they have wide range of products categories, depending on technologies, modules, fusion services, devices and solutions, along with different MCU boards and single-board computers. They also have their flagship products, like SenseCap, Rethings, Grove Series, TinkerGen, etc. Seed also provide ODM and OEM services, electronics manufacturing services, Fusion custom PCB assembly services, structural parts, CNC, and 3D printing services. Beside all of this, Seed Studio also hosts huge ecosystem with open source community, technology forums, project hubs, maker spaces and many more. Although this video is not sponsored, Seed Studio generously sent us their two products, Wio-E5 Mini and Wio-E5 LoRa development board, for reviewing and testing, so thanks a lot to them. Okay, now, we will see all the technical details of these boards. We will see how to get started with them, and we'll also create one IoT-based application project using these amazing kits. After that, we will also perform long-distance communication range test of that prototype application. Okay, let's move forward and see the features of these Wio-E5 kits on their wiki pages created by Seed Studio. So, here you can see, Seed Studio have extensive and thorough documentation portal, means wiki encyclopedia, for each of their devices and platforms, which is very impressive and also very helpful for developers. Let's go to Wio-E5 series LoRa devices and modules. Here are the wiki links for devices which we are going to see. You can go through these for more info. Let me guide you through in brief. Okay, so here is Wio-E5 STM32WLE5JC module, the main core of Wio-E5 Mini, and Wio-E5 development kit. Wio-E5 is a low-cost, ultra-low power, extremely compact, and high-performance LoRaWAN module, designed by Seed Technology. It's a compact chip, you can see its form factor as compared to this coin. It contains ST's system-level package chip, STM32WLE5JC, which is the world-first SoC integrated with the combo of LoRa RF and MCU chip. Means this module is nothing but a SoC system-on-chip, which having two main cores inside. Those are ARM Cortex-M4 MCU and Semtix SX126 series LoRa chip. It supports FSK mode and LoRa with these frequency range bandwidths. It can be used in LoRa mode for EU868 and US915 standard, therefore, we can use it for designing of various IoT nodes. You can know more about this module on its wiki page. Like its comparison with RF95 module. Various features. Typical applications. Factory AT firmware configurations. Clock configuration. Hardware pinout. Electrical specifications. Datasheet and documents, with thorough quick start guide about connecting this module to the things network via AT commands. Then, next thing about how to program this module with custom firmware using STM32 programmer. All this information is given with details on this wiki page. Okay, so it was all about this Wio-E5 module. Now, let's explore two development kits built around this amazing LoRa module. These two, Wio-E5 Development Kit and Wio-E5 Mini. Let's see about them in detail. First is Wio-E5 Development Kit. As they says here, Wio-E5 dev board embedded with Wio-E5 STM32WLE5JC module that supports LoRaWAN protocol on global frequency band. It lets out full GPIOs of Wio-E5, supporting various data protocols and interfaces including RS485, Grove, male-female headers, etc. It would be a perfect choice for fast testing and rapid prototyping of your LoRa IoT projects. You can see here, it has rich interfaces developed to unlock the full functionality of the Wio-E5 module. It has let out full 28 pins of Wio-E5 and provides with rich interfaces including Grove connectors, RS485 terminal, male-female pin headers for you to connect sensors and modules with different connectors and data protocols, saving your time on wire soldering. You can also easily power the board by connecting the battery holder with two AA batteries, enabling temporary use when lacking an external power source. Dev kit comes with these components: SMA antenna, battery holder and Type-C USB cable. Let's see the unboxing. Okay, so here is the pinout of E5 development kit. You will find all this on Wiki page. Then next, here are the important features of this board, like ultra-low power consumption, supports global LoRaWAN frequencies, and it has long-distance transmission range, up to 10 kilometers in ideal open area. Let's see these features on Wiki page. Wio-E5 Dev Kit has a rigorously documented and informative wiki page. Consists of information about its features, hardware overview, specifications, typical applications, information about factory AT firmware, clock configuration, instructions for getting started, quick start guide of AT commands, instructions for how to connect and send data to the things network, and how to build your own custom application with STM32 MCU package for STM32WL series SDK. Here on Wiki page, in specifications, you can see the power output is up to 20.8 dBm. In next video, we will check its transmission range. This board requires 3 to 5 volts supply. Please note that output voltage range is 3.3 volts or 5 volts depend on interface. Then here, it supports all these LoRa bands or frequencies and all these modulation schemes. All this information, you can go through it for more detailed knowledge. Links will be shared in the description. So, how we can use this dev board for these applications? First, we have to configure it using AT commands. We will see this in a minute, but before that, let's see another board sent by Seed, which is miniature version of this development board. This is Wio-E5 Mini. Wio-E5 Mini is a compact-size development board suitable for the rapid testing and building of small-size prototyping design of your ideal LoRaWAN wireless IoT device with a long-distance transmission range. Like Wio-E5 Development Kit, this board also embedded with Wio-E5 STM32WLE5JC module that supports LoRaWAN protocol on global frequency band. It lets out full GPIOs of Wio-E5. This board would be a perfect choice for fast testing and rapid prototyping of your LoRa IoT projects. This board comes with all these components. Okay, here you can see hardware specification of this board. This board has CP2102 chip, which is USB to UART bridge controller, useful for serial communication with this board using AT commands. There are two types of antenna connectors on Wio-E5 Mini: IPEX MHF and SMA. This is LoRaWAN chip, whose full pins are let out on these headers. This is power supply connector header, where you can provide power of 3.3 volts to 5 volts. Here is the pin-out configuration of Wio-E5 Mini board. You can also know more about this module on its wiki page. Similar to Wio-E5 Dev Kit, Wio-E5 Mini also has very informative wiki page, consist of information about its features, hardware overview, specifications, typical applications, information about factory AT firmware, clock configuration, instructions for getting started, quick start guide of AT commands, instructions for how to connect and send data to the Things network, and how to build your own custom application with STM32Cube MCU package for STM32WL series SDK. You can go through it for more detailed info. Links will be shared in the description. Okay, now let's see how we can configure and program these boards. Since Wio-E5 is a LoRaWAN chip with an MCU, there are three main ways to utilize the Wio-E5 dev board. First is connecting Wio-E5 dev boards to PC via USB and control by AT commands. There is a built-in USB to UART function on board. You can just simply connect the Wio-E5 dev boards to your PC with a USB Type-C cable and use serial communication software to send AT commands and read data from the boards. Then second method is connecting Wio-E5 dev boards to another mainboard via UART and control by AT commands. For example, connect Wio-E5 dev boards to Arduino Uno via UART and send AT commands and read data from Arduino Uno through Arduino IDE's serial monitor. And the third method is bare metal programming, means developing user application by using SDK. You can build your own custom application with STM32Cube MCU package for STM32WL series SDK by using STM32Cube Programmer, which is the SDK officially provided by STMicroelectronics. To download this SDK resource, go to wiki page of Wio-E5 module. Please note that this process will erase factory AT command firmware permanently. Okay, now let's see how to configure these modules using AT commands. As there is very weak network coverage of the Things network, Helium network and other LoRaWAN service providers in our office area. You can see these coverage maps of LoRa IoT gateways and networks. So, we decided, we will go for point-to-point communication between two LoRa nodes, means between two Wio-E5 LoRa development boards. We're also going to design one DIY project using same P2P method, but before that, let's see AT commands documentation given by Seed Studio. Okay, now let's take overview of AT commands specification guide. You will get this PDF document on wiki page of Wio-E5 module. We will share its download link on GitHub, as well as in video description. So let's see. As we said earlier, Wio-E5 is a LoRa SoC, which comes with Groove-E5 module. Wio-E5 Mini and Wio-E5 Dev Kit have factory or default firmware, which is AT commands firmware. We have already discussed that Wio-E5 SoC is embedded with two chips. One is STM32 ARM Cortex-M4, and other is Semtix SX126X LoRa MCU. So, This document is intended to describe a command interface implementation of LoRaWAN class ABC protocol. So, these all features, like supported bands, modem MAC commands, maximum 96 channels, maximum 255 bytes RF frame, and so on. You can go through them for more info. Let's move forward. As you can see, this is a vast document. The best way to explore and understand is, I will walk you through the important parts. So, down here, you will find the conventions, symbols and formats of AT commands. Like, for example, conventions like, command is case insensitive. All commands have response. Command length should never exceeds total 528 characters. And default UART configuration. Etc. Then, symbols, if you want to query or set the value for command. Then, here are the error codes to identify the syntax or errors in commands and communications. Then down here, you will get all the information about different band formats, frequency, and channel configurations. Then, going further. Here are the detailed explanations for each command. For example, commands like AT, version, ID, etc. You can go more deeper if you want. But first, let's see all these with an example which we are going to use in our DIY projects coding. For that, let's go down in test commands section. Let me show you. This one. As they said here, test command is not like other command. It is a serious command, which includes several sub-commands. These are sub-commands. Like this, RFCFG. Means, set RF configuration in test mode. Let's see this with example they have given here. So, this is the command. And here is its format. Here, they have listed each parameter. Like, frequency, spread factor, bandwidth, transmit and receive preamble, power, CRC error checking, and public LoRaWAN status. Then down here, they have also given example of how to transmit LoRa packet in test mode. So first you have to set the mode as the test mode. Then, set the RF configuration. Then you can transmit data in the form of packet or hex string. Using these two commands. TXLRPKT and TXLRSTR. These are the return responses for these two commands. So this was all about transmitting LoRa packets. Now, let's see the commands for LoRa packets reception. Hence, at receiver, you have to enter these given commands to configure Wio-E5 LoRa boards as a receiver. Command sequence to receive LoRa packets. First three are same as of previous. But this is the command which configures Wio-E5 to enter into continuous reception mode. And this is the response of receiver when it receives a LoRa packet. It consists of RSSI SNR, data length and data information also. So here, very important, please note that LoRaWAN can receive the messages only in hex format, whereas it can transmit in both hex as well as in string format. So, as we said earlier, in our DIY project, we will use these two command sequences. Since we are going to use Wio-E5 Mini and Wio-E5 Dev Kit in P2P, means point-to-point LoRa communication mode. Alright, so this was all about AT commands specifications and configuration of LoRaWAN module. You can know more about other LoRaWAN modes and commands in this document. Now let's go back to our presentation and see demo of these AT command sequences. Let's see how to configure and communicate using AT commands. Here are the two LoRaWAN dev boards. Wio-E5 Mini and Wio-E5 Dev Kit. Let's connect them to laptop using their Type-C USB cables. You can see, when you connect them to the computer, in the device manager, they will get listed as serial devices. Here you have to note the COM port numbers for the connected LoRa boards. We will be using Arduino IDE's serial monitor to communicate. So here, we have opened two instances of Arduino IDE. Then select COM ports, which we have noted earlier in Device Manager window. After that, open serial monitors to enter the AT commands. Here, don't forget to select baud rate as 9600 and these CR and NL settings, as shown here. Okay, now let's enter the sequence of commands which we have seen in AT commands specification guide. Here on the left-hand side is the LoRa transmitter. We will use this Wio-E5 dev board as a transmitter. And on the right-hand side is the Wio-E5 Mini, will be acting as a LoRa receiver. Now, let's enter the given commands one by one for each device. Pay attention what responses we are getting for each of the command. Okay, now configuration is complete. Let's send the LoRa packet from sender. First we will use txlrpkt command. And the result is, you can see, we received that data in hex format on the receiver's side. If we send data with the txlrstr command, means data in string format. It is also getting received in hex format. Here, please note that you have to set the LoRa frequency or band as per your country and region. As we are testing it in India, we have set it as standard IN 868 band. Likewise, you have to set it as per your country's LoRa standard allocated by LoRa Alliance. Alright, so this was all about theory of Wio-E5 dev boards. In next part, we will build one point-to-point LoRa application using these LoRa dev boards. And then test its long-distance transmission range. Okay, so, in this way, we have seen detailed review of these amazing LoRa development boards, Wio-E5 Mini and Wio-E5 LoRa Dev Kit, manufactured by the Seed Studio. We have seen its unboxing, features, specifications, datasheets, AT commands configuration guide, and we have also seen demo of serial configuration of these boards via AT commands. In the next part, we will see one DIY project using these boards, real-world application and transmission range testing. Stay tuned for more updates. Meanwhile, if you want to purchase these LoRa boards, you can directly go to Seed Studio's website. Links are shared in the video description. Alright, stay tuned for more projects and tech updates. If you face any difficulty in replicating any of our DIY project, feel free to ping us on Telegram or WhatsApp. You can also send us email at support@make2explore.com. We would be happy to help. Thank you.